Okay, hello guys. Today I'm going to be guiding you guys through how to code your user control. This is part two. If you haven't watched part one we tried to code the drivetrain, and in this part I'm going to be teaching you guys how to code essentially any other component in your robot for user control. So first I want to talk a little bit about the goal of programming. I'm going to be talking about this every video pretty much for programming. Um, so essentially the goal of this is so that when we press like one button, it like conducts a certain motion in the robot, and then when we let go, it stops that motion. Um, and then if we want, we can make it go in like two different directions using two different buttons. So that's kind of a little bit about the goal today. So now I'm just gonna guide you through on how to do that. Once again, I'm on my Chromebook because that's where I started my original code. Also on my Chromebook because it's kind of easier to teach it, especially if most of you guys are using your Chromebooks to program it. It's essentially the same. It's just in terms of files, I know that Google Drive is like attached and linked, so it gets a little bit confusing if you don't have that. So now, if you don't remember how to open it, how to open your VEXCode is you press like the little search key on your Google Chrome. If you're on Windows or Mac, press like your Windows key, or I don't remember what the one on Apple was, but like the equivalent of your Windows key. Um, for me, it's already here when I press it because I use it relatively frequently, but if not, you just search up VEXCode IQ, click it, let it load, and how you open your file is you go over to File. Don't do it here because this is a new file and it's gonna not link with your drive, so you want to go to Open. Typically by default, it'll open wherever you saved it last. I saved it in my Google Drive within many folders. But if just recall where you stored it last is what you have to do for this part. You click open, or you can double click the file, whatever works best for you, and you get back to your old code. What did I drag? Okay. First we want to initialize our devices, like we did last time. We want to add a device, a motor. I'm going to use an example of kind of a lift equivalent, but it's a bad lift. As always with everything that I build, it's a bad lift. I'm going to choose port 1. I'm not 100% sure it's this one, but we can change it later if we need to. That's supposed to say lift. You can name it whatever you want. You can name it, if you have two motors for your lift, you can name it left lift, right lift. If you have a claw, you can name it claw, whatever you want. I'm just going to set these default things because I don't remember if it's reversed or if it's port 1 or whatever, but you guys know how to change that. I taught you how to do it in the first video. You should already have your left drive, right drive, and controller in there, so we don't have to worry about that. Now, if you remember from part 1, I kind of talked about what events are. Events are kind of crucial in order to have stuff happen, because it's basically stuff that's constantly being checked. It's constantly checking, is the axis changing? Is the axis changing? Is the axis changing? And if it does, it runs the code below. So think about, I want you guys to think about this. In this code, we're going to be using buttons. So these over here on the same set, on the opposite side of the same ones, we're not using the joysticks, so the joysticks are already linked to our drive. So basically when one button gets used, unless you want the things to happen at the same time, don't use them again. So what block of code of events seems the most reasonable for this? It's going to be this one because it's talking about buttons. This on our controller specifically. This one talks about our brain. This one talks about our brain. This one talks about controller axes, which we use for our drivetrain. And then the other ones are literally irrelevant to the controller whatsoever. So that gives us kind of a big hint. In this video, I'm going to program, let's see, decide first what buttons you want to program it to, and then check your controller reference to see what buttons that would be. So I'm going to do F up and F down. So F up moves in one direction, F down moves in the other direction. If you want to use these, same things applies. This is called R up and R down, I believe, and then this is left or L up, L down. It's pretty self-explanatory in this list. So let's say I want to program F up first. We're going to change it to F up. So essentially, the first thing that I want to do is that this is when F up is pressed. We want something for when F up is released, because if you think about it, F up basically tells it when to start, but it's going to basically keep going infinitely if we don't tell it when to stop. Because if we tell it to run for a set amount of time, what will happen is it'll kind of have an error where it's like, oh, I want it to run for 1 second, but what if I let it go and it's still running for a whole second after I let go? Matches are only a minute, so a 60-second match, 1 second is pretty significant in terms of error. So when we can actually right click, so right click is like click with 2 fingers, or like click in like, most key trackpads don't have this anymore, but just click with 2 fingers and then click on duplicate. That'll basically create another copy, and you let go and you press down. If we search this, we can say when it's released. So basically, in this section of code, we're going to tell it to start spinning, and in this section, we'll tell the motor to stop spinning. So first, I want you guys to think about which block of code tells it to start spinning and not tell it to like spin a certain amount. It would be this block of code. We have to change it to the appropriate motor, which is left in our situation. In my scenario, it could be anything else for you guys. And then in this section, how do we tell it to stop? This isn't a block of code that we've used before, but it's this one. It's pretty self-explanatory. Whenever it's released, we want it to tell it to stop the motor, so you have to change it to the appropriate motor. But you'll notice that we don't have any velocity. By default, these motors run at 50% speed, but let's say we don't want it to run at 50% speed. Let's say we want it to run at 80. We have to change the motor name as well. Never run it above 95. Don't do it. You'll burn out your motor. It's over. Resources are limited. Motors are expensive. Don't break the motor, so don't run it over 95 is my suggestion to keep your motor safe. Now, this is all the code you need to move it up, but let's say you want the motor to move in the opposite direction, because like imagine a claw. You need it to open, but then you also need it to close. Imagine a lift. You want it to go up, but you also want to go back down. So if this is a lift, we also want to be able to go back down. So a really quick hack is to actually right-click this top orange block. It'll duplicate any code below it. But I want you to notice what are things that we might need to change in this code. So one is that this is talking about F up. We also want F down. Pressed is correct. Lift is correct. Or velocity is also correct. But we want it to go in reverse. Basically the opposite direction of what this block of code has. We also need to duplicate this because like F up is released, F down also has to be released. So the only thing we would change here is F down. This is all the code you need to code anything. Basically these 4 like chunks of code. I'd suggest to try to kind of leave your stuff structured. So I'm going to go on a little bit of a spiel about comments. Comments are blocks of code that have no relevance to what actually happens. If you notice how it's gray, what that means is that it does nothing to your code. When it runs, it'll ignore it. But it's helpful for you to recognize what is actually what is actually doing what, because once you have a lot of code, what will happen is you'll lose track of everything. I try to keep it in nice little organized chunks. So this is like this up here is one chunk, this is another chunk, and then this down here is another chunk. So this is for a drive code. So you can just write in drive, and then this is also for a drive. Actually, I'm going to call it right drive, and then this is left drive. And then this is just kind of setup. So I'll call it setup, just to help me identify stuff better. And then down here, this is lift up. And then this is lift down. I'm not going to worry about these because they're close enough where I can recognize it. If I have something like I want to add a claw, what I'll do maybe is kind of attach it mildly lower like here, and then I'll be like claw open, and then attach a claw closed in this section over here. That's all the code you need to do this. Next, I will be showing how to download it to your code.
Okay guys, so I'm now on the floor with my robot, my computer, and then I also have my smart IQ cable, and then my compiling cable, which is my USB type A to USB type C. Talked about this in our last video. This is what we plug into our controller. Actually, forgot to put my controller in frame. So right now I have my little lift mechanism. Once again, not a good lift mechanism. Don't use this design. It's just for educational purposes. What I have to do is I have to plug in my cables. So we plug that in here. And then I also plug this cable into port 1. Because that's what I programmed it to. Now remember, now I have to plug in this into my robot somehow. 1, you can plug it into your controller. 2, you can plug it into your brain. Either one works perfectly fine. I like this because it charges this controller. Your controller always gets neglected to charge until the last minute. Talked about this last video. And then I'm just gonna download my code up here. So remember, by default, it opens up to your code. So if you ever like turned it off, so I'm gonna shut it off for a second. If you turned it off and you turn it back on, this is not your code. You want to go over to Programs, UserControl, and then press Run. You can see my drive code still there. But now we want to test our lift mechanism. So remember, F up should go in one direction, and then F down should go in another. If yours needs to be reversed, you can reverse that, but for mine, it doesn't actually do anything, so I don't care. So, okay, that goes down and that goes up. Okay, wow, this is really fast. And my code is only 80% speed, as opposed to the max 95%. This is just a demonstration of why my build is a bad design. So I'm just gonna reduce it down to 20% speed, just to show. Then re-download. As you can see, I have big gear to small gear kind of thing going on. So if you know what that means, maybe that can help you with your robot design for what not to do for a lift. Because as you can see, this has literally no strength. So now if I run the code, so you can see that when I hold it down, it moves, and then when I let go, it stops, which is what we wanted to do. That's all for this video. I did not want to download it again. I probably accidentally pressed that. That's all for this video. Once again, if you have any questions, feel free to reach out. The next video I'm going to be doing is the autonomous programming. So definitely watch that next.